Since 2008, the Millis Robotics team has designed, built, and used robots in competition. Team Alarm has inspired the community through their dedication to the pursuit of electrical and mechanical engineering and robotics excellence. I'm Miles Fitzgerald. Join me in following their journey.
FIRST is an organization, and the acronym stands for Inspiration and Recognition of Science and Technology. FIRST was created by Dean Kamen and Woody Flowers in order to inspire young students to become America's future engineers. The premise of FIRST is that students work alongside adult mentors and get hands-on guidance and are able to be inspired by people who work in the fields of science and engineering, the same way a student might be inspired by an athlete. There are 4 levels of FIRST. There's an elementary school Lego League in which students build Legos. There's a middle school Lego League in which students build Lego robots. And there's 2 high school leagues. There's Tech Challenge, which is smaller robots. And then there's FRC, which is the big robots. They're 3 feet by 3 feet, 5 feet tall. And Millis High School is a part of this. We participate in FRC, the highest level. And the name of our team is Alarm. So Nick, what is Alarm?
ALARM is an acronym which stands for A Lot of Awesome Robot Makers, which is our team based here in Millis. We have students from Millis and students from various other towns around Millis. There are a multitude of mentors that help out our team and inspire our students, such as Mr. Miller, Mr. Chen, and Mr. Bertram, who is our lead mentor.
Team 2079 Alarm was founded by Andrew Haggerty in 2007 as part of his senior project. We've competed for the past 4 years and are starting our 5th season of competition. We look forward to having a great year, and we know our season starts when FIRST gives us a brief video explaining the game we have to play and our kit of parts.
This year's FRC game is called Logomotion. In order to score points, we need to construct a robot that will quickly and efficiently take these tubes and place them on these pegs to score various points. We also need to construct a mini-bot that can climb a 10-foot pole that must be deployed from the original robot.
At the beginning of the season, we broke up into multiple teams. We formed teams to do, first of all, the field elements. That was finished, then we went on and we came up with some concepts for movement for the base, for the getting the robot to move around. The next thing that was worked on, we had a group that was investigating different ways to lift and manipulate tubes, and we've come up with what I think is a pretty cool idea. Looking forward to seeing it come together. It's starting to, but we've got a little ways to go. And then, of course, how can I ever forget the software? Without the software, none of this stuff would work. It's a good team, good year, and I'm looking forward to a lot of fun stuff.
We have old jaws, we have new jaws, okay? We have no idea how these two work. Octopus is the idea that we have an array, whatever, of suction cups, right? We have a vacuum source. We can make one if we have to out of a piston, or like reverse it. And then the other one is the idea of a claws. This one's probably the easiest one to mock up, because really we're almost talking about puppets, right? And what does a claw maybe need to be shaped like? How does it feel to manipulate it? And this guy. So we got the jaws. Everyone loves the jaws. We haven't tried this, and this is pretty obvious, but we should still try it. And then we should look at them all, and hopefully, what I'd like to do, if we can, is tonight decide on which one of these we're going to go with.
Okay, so the point of the game, basically what we're trying to do is take a tube and put it up on a rack. So we've got a couple different ideas to do that. We could use suction cups to pick it up and grab it. We could use a Jaws gripper claw that would use roller belts to pull it in. Or we could even use almost like a lobster claw to basically grab the inner tube and put it in. So over here we've got some examples. But one idea is to have sort of like an A-frame design with a pneumatic cylinder, a pressurized linear air cylinder to move it up. We could make an elevator mechanism to move it up and down, or we could use some sort of rolling motor on a pivot point to move it around. But basically we need to take inner tubes and put them on 3 different levels of raised pegs. And those are the 3 possible ways we got right now to do this. Probably like 10 pole climbing robots in the fastest one. is basically what Austin was saying. So it clamps on, rides up, just drives up.
But it doesn't have any claws or anything. It's just there's an indent right there. So but you see, there's one wheel like that, but we have it like on a kind of like a pivot system. We have it like that, so it can only expand, go out to the part.
Spring loaded, probably.
Yeah, it's like spring.
If this is our drive face, we're also going to use a manipulator. This year we're thinking of having a telescoping pole that extends at the beginning of the autonomous period. And on that pole is going to be a trolley. That trolley is going to carry a claw, and that claw is going to pick up tubes. And then it can bring them up the elevator and drop them off on pegs.
This is what we came up with. It's a roller claw. The idea is that we can roll tubes in by sucking both rollers in. This claw rests on an elevator. It goes down to the floor, sucks a tube in. The elevator lifts it up. We can rotate the orientation of the tube by spinning the rollers in opposite directions. And then we spin both rollers out in order to release the tubes onto the peg.
The mini bot is held to the pole with these two very strong rare earth magnets. Each of these can exert about 35 pounds. So it's like when it's stuck to the side, the mini bot itself weighs about 70 pounds. The mini bot is powered by two DC motors, and the switch on top is set up to turn on with this limit switch. Oh, there it goes. When it hits the top, it turns off by hitting that white button. The main bot is designed to grab onto the side of the pole, climb up to the top of it, turn itself off, and then come back down to the earth. Safe and work. There you go. There's the mini button.
Welcome to the Alarm 2011 Electronics and Controls Lab. What we've done here over the last few weeks is create the control system for our robot. It is based on a industrial compact Rio, and this compact Rio is the computer that drives the entire robot. We have two basic kinds of inputs and outputs. Digital, basically what your computer runs on, and analog, which has to do with voltages and controls, things like that. Our control system this year consists of 6 motors and a set of pneumatics that control the deployment of our mini robot. The 6 motors are controlled with 2 kinds of motor controllers. One, they're called Jaguars, and the others are called Victors. Right now, you're just looking at the lab mock-up, but all of this is nicely wired onto our robot. The software that runs this robot is developed on laptop PCs. The programming language we use is a technology called LabVIEW. The control system this year uses 2 different kinds of controllers. This Logitech controller here is used to drive the robot. It implements a tank steering method where the left and right drivetrains are operated by separate joysticks. The manipulator is controlled by this kind of joystick here, and this raises and lowers and deploys the game pieces. While the robot is running, the joysticks are connected into this little laptop computer here, which has a dashboard displaying the current status of all the robot operations. And that, in summary, is our robot control system.
Hi, I'm Sam Worthington, and I'm a member of the Alarm Robotics Programming and Electronics team. We're currently working on a variety of tasks, for instance, developing all of the software and controls on the robot, integrating a control system to work with our software, and also incorporating a variety of laser sensors and mechanical limits onto the robot so that we can determine different increments of placement for tubes on the giant rack, and while simultaneously attempting to track small pieces of tape on the ground so that a robot can function in autonomous mode, meaning without human control.
Through the build season, we decided that the elevator idea we had going wasn't very good. It has a lot of tangling cables, there are a lot of points at which the elevator would jam, so we decided to make a new design. The new design is very compact when it rests. What it does is there's a pneumatic cylinder here that will lower down to the ground, and we don't have a claw attached yet. But when we do, it'll roll in a tube, and then we'll pull it back in, bring the tube inside the robot so that we can't get our claw hit. And then this whole arm is going to lift up, and we're going to be able to drop a tube on the top rack, the middle one, or even the lower one. The benefit of this design over something like the elevator is the elevator has a lot of jamming points. You'll bring it up and then it won't come back down because it gets jammed or something. This arm is very simple because it's 2 bars that pivot on a steel rod. It was easy because we could buy bushings from McMaster to make it spin correctly. Simple, it requires fewer motors. The elevator requires 2 motors, this one just requires 1. It's also good because the elevator design that we had our claw hanging outside of the robot for the entirety of the match. With this design, when the claw's outside the robot, we can simply drag it in, and that way other robots can't hit our arm and potentially break it. So it's a much safer design to have going in competition.
So, along with our new manipulator build, we needed a new claw because the old one didn't fit properly. So, what we have is this plexiglass sheet that the tubes will ride on, and they'll first hit the top of this sheet, and then they'll be rolled in by this roller. This piece of tubing prevents them from being flipped over and around and getting stuck on the claw. It's ran by a Fisher-Price motor. It's adjustable, so if we find that the tubes are too big a competition, we can either move this up or down in order to compensate. So all in all, it's a pretty good design.
good regional up at the Greatest State Regional Week 1, and here they are all the way to week 5, and they're beginning their offensive barrage early.
Team Alarm's gonna have to get that triangle moving here. He's got it in grasp. Tigertron's helping out the Blue Alliance with the blue square up his left. Deflated Cuban hand trying to get that out of peg. That's gonna be tough. Team Alarm for the Red Alliance. Oh, close to the top to the middle row, but still successful.
Robots doing it as well. Rambots can't quite home in that triangle. Looking to cap off the logo. His alarm. They are just in place. They get the triangle piece in their possession. Now they're just going to think mini bot here. Alarm going back for another score. Back for the pick. Races on. Up goes the mini bot. First place for 78. Rambot's trying to get lined up here. And they get one in time and they cannot. That concludes round at number 7 while the official will spring in just a moment. And now the score goes up on the board. And we have a victory for the Blue Lions, 60-12.
Hit the top and then come back down. Let's see if it works.
That's it. You hit the red button again. Are you serious? Hola. Me llamo. No, I'm just kidding. And go.
Okay. What is alarm? What is first? Are you filming?
Yeah.
First is an organization that stands for. I was adding that. That was good.
Okay. All right. Go.
Wait, stop.
So, alarm. Franklin, Norfolk, and now,
That's good. I'm Max, and I'm eating mangoes. See this? I can't. So Nick, what is a lot?
reposition, and that's our team name. Now, that's our team name, and
So Nick, I've got some parts
acronym which stands for a lot of awesome robot makers.
I can't do it.
Robot makers.
What is?
Part of surrounding.
Don't even go.
Do you need an iPod or something? Do you need music?
Of students.
What was that? Sorry. You should like sing it like what, and then you can come in and go like, what is alarm? That'd be cool.